So in this video, I'm going to talk to you a little bit about graphing. So first of all, there's a few things that we need when we're making good graphs. Now, I want you to keep in mind, I'm going to do this as if I was doing the graph on a piece of graph paper. I would highly recommend that you, instead of using graph paper, that you start to graph things digitally, and so I will show you in class how to use Desmos as well as Excel to graph things digitally. Again, Desmos is probably the best one because you can very easily access online from anywhere. You don't need special program, and it's very, very easy to use. So that's what we're going to be using for most of our in-class work, but this is just to show you how we are graphing, and a lot of these things still will apply to us as we move it to digital. So making good graphs. So there's a couple things I need you to be doing as we make a graph. So we're going to be graphing it, right? And it should look kind of like this. I need you to make sure you're labeling each axis with a variable. Okay. We need to use a consistent scale, and I'll talk to you about how we kind of come up with our scale. Nice thing is, for grade 8, it's very simple to come up with our scale. As we get into grade 9, 10, we need to be a little bit more careful. If you're doing this on paper, you need to make sure you use a ruler. There's nothing worse than a graph that's got lines that are all squiggly and I can't really tell where anything's going, or it looks like this, and that's not really what we want. So I want you to be using a ruler, and obviously if you have graph paper, that helps too. Now the last two things, we do want to give our graph a title, and we want to give titles or labels on each axis as to what that axis is related to. Okay, but I can only do that if I'm given information about what my different variables are. If I don't have that information, I can't include it, and so I would still just label the axes with the variables, but if I don't have any more information other than letters, I'm just going to leave it like that. Okay, so today we'll work with some that have titles, and we'll use that. So if I was given something like this, so it says the maximum number of students who can go on a field trip depends on how many teacher supervisors there are. Let S represent the number of students and T be the number of teachers. So for us, where we are in the CBE, our ratio for grades 7 through 12 is we could take you on a field trip so long as for every 13 kids we have at least one teacher. So if I have one teacher, then I can bring 13 kids. So that's what this is saying here. So S is the number of students. So the number of students, the maximum number of students, is equal to 13 times T, and T is the number of teachers. Okay, so we'll just kind of write that out. It means that the number of students, because it helps to say it in words, the number of students equals 13 times the number of teachers. Okay, so that's really what our equation is telling us here. Okay, all right, so the first thing I need to do if I'm going to graph this relation is I got to come up with some values here. So I'm going to create a table of values that I'm going to put on my graph. Okay, now I have to determine which one is my X and which one is my Y. Okay, so I'm going to read this again. The maximum number of students who can go on a field trip depends on. Okay, that's the key here. Depends on. So the number of students depends on the number of teachers. Okay, and what you're going to learn as you go through and you make more graphs in science is we have something called a dependent variable and an independent variable. Okay, or we have, the dependent variable and the controlled variable. So the controlled variable is what we would put along our x-axis because it's the thing that we can keep track of or that we can control and manipulate ourselves. Then we have the dependent variable or the responding variable, which is going to change based on what we do on our x. Okay, so we are saying the number of students depends on the number of teachers. So teachers gets to go along the x-axis and students will go along the y. So I'm going to put in T for teachers in the x and S for students in my y. So remember, I always go x first and then y. Okay, so if we look at this equation here, I said, well, if we bring one teacher, we can bring 13 students. And really what I'm doing is I'm taking this expression, s is equal to 13t. And I'm saying, well, what if the number of t, or teachers, is 1? So when I substitute in, I have 13 times 1, and 13 times 1 is just 13. And then if I did it again, where instead of looking at the number of teachers being 1, what if I had 2 teachers who could go on the field trip? Well, now it's 13, and instead of filling in 1, I fill in 2 teachers. And now the number of students we could bring on that field trip is 26. So when there's 2 teachers, we can bring 26. Okay? And now you might notice, okay, well, if I bring another teacher, I add 1 teacher, I can add 13 more kids. And so I could keep filling in my table of values. Add 1 more teacher to go from 2 teachers to 3. Add 13 more students to go from 26 to 39. And then next would be 49 and 52. Okay? So that would be how we would get our table of values. Now, what I'm going to do with this table of values, it won't let me copy it. All right, I got to move it onto here. I got to redraw it. Okay. So I'm going to give you the table of values again. So we had teachers, we had students, and we had 1, 2, 3, 4, and it was 13, 26, 39, and 52. Okay, so here's my graph over on the right-hand side. So I've used a ruler to draw 2 nice lines here. Okay, I'm going to indicate using an arrow like this to say that these lines do keep going forever in those directions. Okay, they do keep going forever in both directions. Now, the first thing I need to do is I need to label the axis with my letters. Okay, with the variables. So when I label the axis with my variables, the first one I have is t. That's my horizontal because it's the first one in my table of values. So the first thing I'm going to do is put t down here to say I'm looking at the number of teachers. My other axis gets this label of s, so I'm going to fill in s to represent the number of students. Okay? Now, I also, because I was saying the words, I know that the horizontal axis is the number of teachers. So I'm going to put in that title, number of teachers. Now it's probably better for me to write out the word number, but it's much harder on my tablet for me to fit it. So I'm going to put number of teachers. And then the vertical axis is my number of students. Okay, so I've taken care of my labels where I've put my variables onto the different axes. And I've put titles because I know information about what's going on in the graph. It's not just numbers. These numbers represent how many teachers there are. So I'm going to put that information here. Okay. Now I need to also use a nice consistent scale. So where my 2 lines meet here, where the 2 lines meet, that is 0. Okay. And now I need to create some sort of scale. Okay, so I might say, well, I'm going to just, for the purposes of space, I'm going to count over 1, 2, 3 squares, because I don't want to squish it in too much. I'm going to count over 3 squares and mark that as 1 teacher. And as soon as I've said that this distance of 3 squares represents a change of 1, anytime I move 3 squares, so if I go 1, 2, 3 squares over, that is also now a change of 1, so I go from 1 to 2. If I was to go to my next one and say this is now 5 teachers, this would be an inconsistent scale because this jump, a distance of 3 squares, was 1. This distance of 3 squares was 1. But this distance of 3 squares is 3. That doesn't make sense. It has to be consistent. It has to also be a jump of 1. So whatever I make my first jump, all my other jumps must now be the same. So every time I move 3 squares, I am adding 1 more. Okay? Now I got to do my vertical axis as well, and I'm going to have my scale here. Now I could go up by 1s, but I need to get up to 13, and then 26 and 39 and 52. So as I look up here, I definitely don't have 52 squares. Okay, that's not going to work nicely. Let's see. Okay, well, this really is just going up by 13 every time. So since it's just going up by 13 every time, I could try just making my scale 13. So this is why it's nice in grade 8. In grade 8, most of our questions do end up working like this. On my y-axis, or my s-axis, I'm going to use a different scale. I'm going to say a distance of 3 squares on my y-axis is really a jump of 13. So if I say that's a jump of 13, then when I move 3 more squares going up, that's another jump of 13. Okay, so that's another jump of 13, and 13 plus 13 is 26. And then another jump of 3 squares is 39. So as long as you are consistent and you are going up by the same amount every time, you can use that scale. If you jump around and your numbers don't make any sense or it's inconsistent, that is what is bad. So because I said every time I move up 3 squares, it's a distance of 13, and then I went up 3 more, and it's a distance of 26, and up 3 more, and a distance of 39, that's allowed. Okay? Now I need to put my points of information in here. So my t-axis, I need to move to 1, and 13 on the s. So I need to move to 1 on my t-axis, which is here, and then move up to 13 on my s-axis. So again, it's a little tough to do on my tablet because I can't be super precise, so I apologize if it looks a little messy. I've got 1 and 13. And then I'm going to move to 2 on my t-axis and 26 on my s-axis. So that's 2 and 26. So I'm moving to here. Okay? And then my next one is 3 and 39, and 4 and 52. And this looks like a linear relation. It looks like my 4 dots are all on a line. And it would also make sense, I could have added this in, although I didn't on my original one. I could have added this in. I could have said if we have no teachers, there's no field trip, and no students leave the school. So I can have another one here at 0, 0. That would be fine too. No teachers, no field trip, right? So it looks like my 5 points now are in a nice straight line. And so I could make some predictions. My next one is probably going to be up here because then it continues my pattern. It continues my linear relation. Okay? Now we do need a title as our last thing. So I need a title for the graph. So I could say maximum number of students, and you would want to write out number, on a field trip. There's my title. Great. So I have a nice consistent scale on my t-axis. I have a different scale, but it's consistent on my s-axis. I used a ruler to draw nice straight lines. I have my variables are labeled on my axes. I have titles on both my axes, and I have a title for my graph overall. Okay. Now we'll talk about in class how to do these things digitally. It makes it much easier to graph your table of values. Okay, so we'll do some of that in class digitally. It will make life a little bit easier. Now, one thing to keep in mind, I said it looks like these fit in a straight line, and then a lot of students will be tempted to connect the dots. You need to think, is it reasonable to have information in between these sets of data? So is it reasonable to take, instead of 13 students or 26 students, would it be reasonable to take, say, 20 students? And we would say, sure, that makes sense. But if I want to take 20 students, is it reasonable to take somewhere between 1 and 2 teachers? And that answer is no, it is not reasonable. As much as you dislike any of your teachers, you may not chop us into pieces and only bring part of us on your field trip in order to go. So do not chop your teachers in half. And because we are not allowed to chop teachers in half, we would not connect the dots. So this would be considered discrete data, and that means that the points are not connected because there is no information in between. If there was information in between, we would call that continuous, and we would connect the dots. In this case, don't chop teachers in half. If you do, there's probably some psychological problems, and you might get put away for a while. Okay? So no chopping teachers.